All right, so today we're in section 1.2, solving multi-step equations. All right, so some important information, and if you had Ms. Vorpahl last year, I'm going to kind of pull in some of her strategies that she taught you so you can see the similarity. But when you have a multi-step, meaning more than one step to solve, okay, you need to add or subtract before you multiply or divide. We always add and subtract first to move to the other side. The goal is still the same. You want to isolate the variable. You want to get the variable by itself on one side of the equation. Okay? All right, so Ms. Vorpahl, and if you're new here, you'll catch on pretty quick, taught us last year that the number connected to the variable, they're what? They're best buddies, right? They're best friends. And so we're going to draw a heart around the term that has the number and the variable connected. So if you're best buddies, you want to hang out as long as possible, right? You want to hang out with your best friend as much as you can. So we're going to leave them alone, okay? And we're going to move what's not connected to the variable first. All right, so what's the opposite of 15? Positive 15. Negative 15. So what I need you to do is write the minus 15 directly underneath it. Well, 15 minus 15 is 0. So that's why you're going to put an X through it and cancel it out. Property of equality says do the same thing to the other side. So subtract it to the other side. Now I want a big, long equal sign. Okay? That separates the next step in the equation. Okay? And now I'm going to bring down what's left. So I bring down my 3x. All right. And what is 24 minus 15? Y'all tell me. What's 24 minus 15? It's 9. Okay. All right. Anybody want to just tell me? You don't have to raise your hand. What's my last step to solve for x? Divide by 3, both sides. Very good. Okay, divide both sides by 3. So this is what I call a two-step equation because it took me 2 steps to solve for x, to get x by itself. Okay. All right, I want you to try the second one. See how far you can get on the second equation. All right, see how far you can get. I'm just going to give you about a minute to get ahead of me. All right, I'm going to use this opportunity to learn some more names. Now, I'm going to go by nicknames. It's in your grade book. If you hate your nickname, blame your parent because they put a nickname in there, and usually that's what you go by. All right. Let's see. Josh, what did you do next?
I added 10 to each side.
Uh-huh.
And dropped down the negative 2x.
Very good. Drop down that negative 2x. And 22 plus 10 is? 32. Very good. Now I need one more step. To solve Zoe. Do you know the next step? Very good. Divide by negative 2, both sides. All right. Layla, would you mind grabbing that door for me and shutting it? You kind of have to twist the handle and pull it shut and then let it go. It doesn't latch easily. Perfect. Thank you so much. All right. X equals negative 16. So then all I had to do was do 32 divided by negative 2. All right. My two-step equation. Okay. So now we're just going to kind of step it up a notch. What do you see different about these two problems? We have fractions connected to the variable, but they're still best buddies. Okay. So I'm not going to worry about the fraction to start. I'm going to move what's not connected to the variable first. All right, so let's see. Jose, what do you think you're going to do first? What do you think? How could I get rid of positive 3? What's the opposite? Very good. I need to subtract 3 And if I do it on the left side, I have to do the same thing on the right side. Okay, so we have 3/4 x equals 18. All right, so I don't know if it was yesterday or Friday, but we talked about a fraction being multiplied by the variable. Technically, this is multiplication, guys. So I would divide by the fraction to get it by itself. But what happens when you divide fractions? Do you guys remember that 3-letter acronym? KFC. So what actually happens is if you divide this fraction, don't write it like that. You need to do the KFC. Keep the first one, flip the second one, and change the operation. That's why we flip the fraction and we multiply by 4/3. Now what happens, so again, you should be writing this exactly how I'm showing it. All right, so then you can cross reduce. But whatever I do to one side, what do I have to do? Same thing to the other side. So now I multiply 18/1 times 4/3. All right, anybody want to raise your hand and tell me what you would do next? Okay, there's two options. One way makes things a little bit easier than the other. Jada, what do you think? Yeah, I would cross reduce by what factor? Okay, 3 and 18, reduce it by 3. And 18 divided by 3 is 6. 3 divided by 3 is 1. All right, now I'm ready to multiply my fraction. All right, so what's 6 times 4? 24. So x equals 24/1 or just 24. All right, so now on the left, you see one exactly how I want you to do it. Now I want you to do the same thing to the equation on the right. This is where I'm going to kind of walk around and check on you guys. I'm hoping to, what I'll do is on one problem, I'll check half the classroom. And then on the next problem, I'll check the other half of the classroom, or I'll just kind of be all around. All right, so take about a minute and work out this problem. All right, so add 9 to both sides. Now, one common mistake that I'm seeing is this same sign or different? It's different. So you subtract and take. Did you say -16? -16? And then bring down your 1/2 x. All right, so 1/2 x equals -16. Now, what do we do to get rid of the fraction? All right, you have the other one to look at. How do I get rid of the fraction? KFC. Did you flip the fraction to 2/1 and then multiply the other side by 2/1? Okay, so now x equals -32. All right, just kind of nod your head. So did y'all get that right? Or shake your head, you didn't get it right? Okay, don't lie. I'm not asking you to raise your hand. Sometimes you're like, everybody else is raising their hand, so it gets a little awkward. Okay, but it looks like you're doing well. So now we're going to add another step to this. Okay, now you see more than 2 terms on one side of the equation. So we need to review something called like terms. So 2 terms are like each other. I'm going to highlight them. These terms are like each other. Why? Why do you think they're like terms? Just tell me. They both have an x. They both have an x. So when they are like terms, we can combine them together using their coefficients. That's the number out front. So what do you think would be 8x minus 6x? What's 8 minus 6? Pay attention. What's 8 minus 6? 2x. Very good. So 2x minus 25 equals -35. Now this looks just like the problems that you were just doing. Okay, so it took combining like terms, and now this is just another 2-step equation. All right, so we can draw our heart around the terms that are best friends that we're going to keep together. All right, and I want you to finish working out this problem, okay? If you'd like to, if you're done and you want to start the next one, you can do that as well. All right, so now we're going to add 25 to both sides first. Add 25. Now cross everything out. I know that these steps seem kind of tedious, but it really does help you realize, okay, that's gone. It's 0 now. So now bring down what's left. 2x equals negative 10. Divide both sides by 2. And x equals negative 5. All right, so I know several of you have already started the next problem. Okay, but what I want to start with is what terms do you think you can combine? As soon as you see more than 2, there's something to combine. Okay, what 2 terms do you think you can combine? Over here, tell me. Right, because they both have an n, right? So look at the signs in front of each term. Is this same sign or different? Same. So you're going to add them together and keep the common sign. Okay? Same sign, add and keep. Okay? Add them together, keep the common sign. Negative 12n. All right? Does everybody see how I got negative 12n? All right? Plus 17 equals 23. All right, now I'm going to cut you loose again. Okay, I want you guys to finish this problem. All right, finish this problem. I know several of you have already been working it. Okay, let me give you a hint. Your answer is not a whole number. Okay, so if you didn't get a whole number for your answer, then you probably got the right answer. Okay, if you did get a whole number, go back and figure out where you messed up.
So would you bring it down into the negative 20?
Yep.
Would you bring it down to negative 20?
Yes, absolutely. That's the correct answer.
You said it's not a whole number?
It is not a whole number. The answer is not a whole number. You need your calculator. Close. No, somebody- 3 takes it down to 20. 3 more takes it down to 17. 6. Okay, now keep going. Keep on now.
You should let me get this part.
Oh, right, get that negative in there. Yeah, it is hard to see. All right, good. Been good, guys. Biggest number. If you reduce by 2, you'll just reduce it again, which is no big deal. You just want to keep reducing. Okay, so this is the part that kind of puts you up. So once you kind of divide by a bigger number, this is actually a fraction. You're going to use that. Does that make sense? Okay, but your work looks perfect. Just pick your answer. Okay, you did the same thing. So your work is perfect, but this ends up being a fraction. So subtract 17 from both sides. Now bring down what's left. Negative 12n equals 6. Now here's where things start getting a little different. In our minds, we like to think whole numbers. Okay, so even in our minds, we can tend to kind of twist this around and think our answer should just be 12 divided by 6 is 2. But look what happens. Negative 12 is connected to your variable. So when you divide the other side by negative 12, n equals negative 1/2. Okay, you reduce the fraction. All right, so you are going to see those from time to time. If you get to an answer that's not a whole number, that doesn't mean you did it wrong. Okay, all right, any questions on that? You guys are doing well. Yes. Yeah, if you put a decimal, that's perfectly fine. Yeah. Yes.
For that question, that 8x minus 6x,
Yes.
why would you add it instead of, like, you know how they have do you see the 25? in the
Yes.
equation?
Yep.
Why would you add 25 instead of subtract it like we did on the other program?
That's a great question. Do you see how it was subtraction here? How it was minus 25? So whatever the operation is here, you have to do the opposite to get it to cancel. All right, so that was a great question. So because it was minus, I added it, and that's why I crossed it out. Here, it was plus, so that's why I did the opposite.
So it's always the opposite.
It's always the opposite. All right, and it's that rule no matter if you're doing like the basic equations or the most complicated ones. All right, so great question. All right, let's move on. Just taking it another step. Okay, we are going to do I did one of these. We're going to do the second one. I'm going to save the 4x plus 20 for tomorrow. Let's do this one over here. Okay, negative 2n plus 4 plus 4n equals 23 minus 5. All right, I want to see if you can combine your like terms and get to step 2. All right, so I'm just going to give you about 20 seconds to see if you can get to step 2. Did anybody see something they could combine on the left side of the equation? You want to raise your hand and tell me? Gavin? Very good. So what is negative 2n plus 4n? Very good. So he saw that you could combine the n's, and he got 2n plus 4 equals, did anybody combine the 23 minus 5? What'd you get? 18. Very good. So now it looked like, oh goodness, this is going to be like, there's so many terms there. But once you combine them, now it's not so bad. All right. So I need you guys just to take another minute and go ahead and try to get ahead of me and finish the problem. All right. And then we'll go back and we'll see if you got it right. So just another minute to finish that problem. Okay. Vivian, do you know what your first step would be on this problem? What would you do first?
Subtract 4 on both sides.
Very good. Subtract 4 on both sides. Did you guys do that?
Yes.
All right. Awesome. So 2n equals 14. All right. Next step. Mr. Noah, what would you do next? I have 2n equals 14 left. What would I do? Yeah, divide 2 on both sides. Did you guys get 7? All right, n equals 7. Very good. All right, any questions? All right, next is distributor property. I know that it's distributor property because I see 2 terms inside the parentheses that cannot be combined, okay? Meaning they are not like terms inside those parentheses. 1 minus 5x is not a like term, okay? So how do I get rid of them? The answer is distributor property. The number on the outside of the parentheses must be, here's where they get the name, distributed or multiplied by every term inside the parentheses. Okay? Now, one thing you want to be really careful about is the sign. You want to make sure that the sign is accurate. Okay? So 2 times 1 is 2. 2 times negative 5 is negative 10, and then you bring down the x. Okay, so do you see how I got 2 minus 10x? Okay, now let's bring down the rest of the equation and rewrite it. Plus 4 equals negative 8. Okay, so do you see how this kind of builds on the last one? All right, because now almost every time, I would almost say 100% of the time, when you have distributor property, the next step, you will have some kind of a like term to combine. Okay? So look here. Can someone raise your hand and tell me the like terms that you would combine? What like terms would you combine? Is that a raised hand? Yes. Are you raising your hand?
Yeah.
Okay, yeah, what would you do? What is it?
4 and 2.
4 and 2. Is 4 positive or negative?
Positive.
Positive. So you might see this subtraction sign, but that's connected to 10x. All right, that's a common mistake. Are you paying attention? All right, you paying attention? You looking up here? Noah. Okay, 2 plus 4 is 6. So 6 minus 10x equals negative 8. All right, and I'll give you another minute to finish that problem. Okay, so I see that negative 10x, it does come after, but that's okay. How do I get 6 to cancel out? How would I get 6 to cancel to the other side? Y'all tell me. Minus 6. Do the opposite. So minus 6 cancels it, and I minus 6 to the other side. Now bring everything down. Negative 10x equals, is this same sign or different, guys? Negative 8 minus 6. Same, so same sign, add and keep. Negative 14. What do I divide both sides by? Negative 10. And x equals 7 over 5. Is it negative or positive? It's positive. Why? How many negatives are in the fraction, guys? 2. 2 is an even number of negatives, so that makes a positive answer. Remember your even odd rule for fractions. 2 negatives, positive answer. All right, this next distributive property. All right, last class, it was really split 50-50. How many people got it and didn't? I want you to try to get to step 2. Do this distributive property and rewrite the equation. See if you can get through step 2. All right, Sequest, how are you feeling about this? You want to tell me what you got? Did you do the distributive part? Okay, tell me just the distributive. I'll kind of walk through it with you. So that's perfect. 6 times 5 is 30. Did you guys say minus? Did you say minus? Because 6 times negative 8 is negative 48v. Now bring everything else down. All right? All right, just nod your head if you got step 2. Just nod your head if you got step 2, or shake your head if you didn't. Okay? All right, be honest, because if I see a whole lot of this, I know I need to stop and go back. Okay? Or give me a thumbs down. Like, this sucks. I don't get it. Okay? All right, what like terms can I combine over on the left side? Somebody tell me. Joy.
30 and 12.
30 and 12. Very good. So 30 plus 12 gives me, y'all tell me, 42 minus 48v equals negative 54. All right. Y'all think you can take it from here and get me to the answer? Yes, you can do it. I believe in you. You can do it. All right. Take another minute and get to your answer. See if you can get it before me. All right. Next step. Did you subtract 42 from both sides?
Yes.
Did you subtract? Did you draw your big line underneath that to separate the next step? Okay. If you're saying no, go ahead and do that. All right. Just add it back in. We want to get into a good habit. As you guys can see, these equations are more complicated than the equations you did yesterday. Okay. And it's going to keep building. The equations we do tomorrow, they're not getting any easier. Okay. All right. So negative 48v equals negative 96. All right. Y'all tell me the last step. What do I do? Divide by negative 48. Okay. And v equals, is it positive 2 or negative 2?
Positive.
It is positive because I got two negatives, which is even. So it's a positive answer. V equals 2. All right. We're going to skip the next 2 distributive property. We're going to save them for tomorrow. Okay. But it's the same thing. It's just more practice. These guys, the only way we learn in math is to practice. So that's why there's so many examples in here. Okay. Not too bad. All right. So it says find the number of miles, that's X, that you need to run on Friday in order to have a mean number of miles per run per day of 1.5. Okay. Now, for some reason, I don't know what happened, but the table got deleted from your notes. Okay. Not a big deal. You do not need to copy down the table, but I do need you to look up here at the screen so you know where we're getting these numbers from. Okay. So first of all, can someone raise your hand and tell me what is the mean? What is the mean? What does it mean? All right. Let's see, Jada. No, that's the median. Cade? It is the average. So I add all the numbers together and I divide by the number of numbers. Except now when I add them all together, okay, so let's go ahead and add all these numbers. 2 plus 0 plus 1.5 plus 0 plus x, okay? So it says add all the numbers together, and what do I divide by?
4.
How many numbers, you include the variable, how many numbers are in that set, are in this table? How many? 5, because there's 5 days of the week that we're counting. So you're going to divide by 5. And those numbers, okay, the sum of these numbers divided by 5 must equal 1.5. So what's different here is usually you have all the numbers over on the left side, and then you tell me what the mean is. Here, it tells you this, but it says, what value does this have to be in order to make that division equal 1.5? Okay? So what do you see about all the numbers on top? Do you think there's anything you could combine up there? Y'all tell me, what can you combine? All of them, right? The zeros, that's really, but what's 2 plus 1.5? 3.5, so let's rewrite this. 3.5. Does everybody see where I got 3.5? Okay. Plus x divided by 5 equals 1.5. Okay. Now, I normally don't see a fraction that has addition with the x and then a denominator. Anytime you want to get rid of a fraction, guys, what you can do is multiply by whatever number is in the denominator. You're flipping it. You guys remember when we flipped it? But instead of flipping the whole thing, you're only going to multiply by the denominator to get it to cancel. Okay, this is where I might lose some of you, and that's okay. We're going to do another one tomorrow, and hopefully tomorrow it makes more sense each time. Okay, so if I flip my denominator and multiply this, my rule says I can do that as long as I do the same thing to the other side. Property of equality. Okay, so if I multiply this by 5, these can cross cancel. If I multiply, as long as I multiply the other side by 5. All right, so now let's bring down what's left. I got my 3.5 plus x out of that fraction equals, what's 1.5 times 5? 7.5. All right, now it's a simple one step. What do I need to do to solve for x? Go ahead and do that. Now, I want you to answer this question. As you're answering it, I want you to answer this question. If you were a betting person, would you bet on yourself to hit your goal of 1.5 miles? Based on the answer for X, that's how many miles you have to run on Friday. No. Okay? Or if it was somebody else. Would your money be on them to actually do it?
That would be somebody valuing my money a lot.
Well, we don't bet, right? That probably wasn't a great example. We don't want to gamble. Okay? X equals 4 miles. Look at how much you ran all week. You didn't even run 4 miles in all 4 of those days combined. And now all of a sudden you're going to bust out 4 miles on Friday. Can you even run 4 miles? I mean, I don't know, right? Tuesday and Thursday, what's some excuses for not doing something that you know, like not accomplishing a goal? What are some of your excuses?
I was in the hospital.
I overslept. My knees were hurting. My foot hurt. I was sick. I had, a cold or something. Who knows? But if you slack off 2 of the days, your goal was 1.5 miles a day. If you had just run 1.5 miles a day, you would be good. But instead, you got to run 4 miles on Friday to make up for your lazy days. Right? Do you see how we can kind of talk about a situation or a scenario? All right? There's more to it. So, just a little extra. All right? And we're going to stop there for today. We got a little bit more to cover tomorrow, but not much.